Hi everyone, welcome
Hi
back
everybody.
to another episode on Space Doll Live. Please welcome Nick and Terry. How are you guys doing?
Hi everybody.
We're good.
Yep.
How's it going? Thank you for joining us, everyone. We're back with another episode of the Space Roundup tonight, bringing you the latest and greatest space news from across the universe. Strap in for another great show. Thank you for taking time out of your Tuesday evenings with us. And I'll let Nick and Terry take the stage. Hope you have a good one.
Cheers.
Okay, cheers.
It's World Space Week, or starting off with World Space Week. So happy Sputnik Day indeed to Chris, who's in the chat already. So thanks for that. Nice timely reminder. There's been a lot happening, a lot not happening if you're NASA as well. They seem to have a very unfortunate large spacecraft that keeps on rolling in and rolling back out of the pad. We were hoping to talk about the Artemis launch this month. Clearly, we're not going to be able to talk about that for a few months now because they've rolled it back yet again. And Boeing's woes continue with all sorts of little technical problems and hurricane problems and all sorts of little issues. They were even thinking of launching just before the hurricane hit Florida, but as you probably heard from the main news, that hurricane did quite a lot of damage to Florida and turned half of it into a lake. So, hopefully by Christmas, we'll be able to talk about the Artemis launch, which currently its bump costs, its delays are costing as much as it's going to cost Elon Musk to launch Starship. So let's just put that into context when we're dealing with a cost of living crisis around the world. We've got a packed show tonight. We've got a lot going on. Got the DART mission. We're going to be talking about some really cool stuff from Enceladus. And I know one of our semi-frequent listeners, a lady by the name of Dr. Carolyn Porco, it's one of her favourite objects in the entire solar system. So we're going to be talking about that. We're going to be talking about the Anon, not QAnon, but the Anon rover, the sample fetch and return rover, which has kind of had to change tack as well. So there's a lot of changes happening. And a few other things, but we're going to kick off with DART. Terry and I were talking backstage before we came on. What an amazing mission that was, to watch that thing it was like having a front row seat to like the set of Armageddon, basically, or Deep Impact. It was incredible, but for real, wasn't it, Terry? That was the thing.
Yep. And you forget that not only is the main asteroid pair orbiting through space, Dimorphos is orbiting around. They're orbiting around their common center of gravity, but you have two distinct sets of motion there, and then of course you have gravitational deflections of the spacecraft on its way there. So while they say it is rocket science, it bloody well is rocket science getting a direct hit like that.
I mean, put this into context, right? You've got a small asteroid about 160 meters across orbiting a larger asteroid about 800 meters across. Okay, you've then got a spacecraft launched just under a year ago, traveling at an impact velocity of 12,000 miles an hour, autonomously navigating itself using a Rishi-Chrétien telescope and a navigation camera based on a CMOS sensor, which is the type of sensors you get in your average camera that you go down to your hardware store and buy these days. Obviously, a bit more sophisticated than that, the software, many orders of magnitude more sophisticated than that, but essentially being navigated autonomously for a pretty much direct hit. And whilst it's flying in towards this thing at 12,000 miles an hour, it's sending back real-time images, obviously with the time delay, the 7 million mile light speed time delay, but sending back real-time images down to 20 centimeter per pixel resolution up until the point of impact, where you can literally see dust on the surface of Dimorphos, the little thing that it hit. Then you've also got a CubeSat built by the Italian Space Agency running in parallel with this that they ejected 15 days before. It's got its own propulsion system, it's got its own thrusters, etc. It's then imaging all of this and also sending back images. On top of that, you've got the James Webb Space Telescope, and you've got the Hubble Space Telescope imaging it from orbit and a Lagrange point in different frequency bands. It's just incredible to even think about how complex this is and how it was done. It was originally designed as a kind of dual spacecraft mission. The European Space Agency were going to send something called AIM initially, which was going to be a kind of an asteroid monitoring system that was going to do the imaging and monitoring while orbiting this dual asteroid system, which ESA have got a lot of experience, obviously, from their incredible success on 67P, the Comet with the Rosetta mission. So that would have been amazing, but they are still sending a spacecraft. So in a couple of years' time, about 2026, we're hoping the Hera spacecraft, the European Space Agency, are going to be launching, which will then go up close and look for the impact crater. And this is the thing, this CubeSat, the LISIA-Cube, the Italian Space Agency CubeSat, was able to do imaging during part of the mission, but obviously it's not able to retain or maintain an orbit around the asteroid. So they're going to be sending another spacecraft in a few years' time to effectively look at what exactly happened up close in terms of where was the impact site, what was the amount of ejector based upon modeling. They hopefully will know roughly how much mass was lost. But this is the thing, you've got not only the impact velocity, and don't forget what this mission is. The DART mission is designed to test planetary defense. If you've watched the movies Deep Impact or you've watched Armageddon, the reality is we're not going to be sending a pair of space shuttles to land on a comet. We're not going to be sending Bruce Willis. We're not going to be, sending nukes up to blow it apart. We're hopefully going to be deflecting an asteroid. Now, we'll go on to comments in a minute, but with an asteroid, hopefully, we have been able to, astronomers have been able to detect pretty much about 90 to 95% of the larger ones, the ones that could potentially wipe out all life on this planet. So the object that hit the Yucatan Peninsula, Chicxulub, around about 66 million years ago, was anywhere between 10 to 15 kilometers wide, hit the Earth in a really bad place, in particular being, kind of sedimentary, nasty sedimentary area near the coastline, the ocean. So all sorts of reasons why it was particularly bad. What we haven't been able to image a lot of, and it's probably about 40%, are the city killers. So if you think that a 50-meter wide asteroid, if you've seen the crater in Arizona, the famous one, Barringer crater, that was created by a 50-meter wide asteroid, an iron asteroid, that basically then went on to form the Canyon Diablo meteorite collection, which there's some of them in the cabinets behind me, beautiful meteorites, iron meteorites. That was only 50 meters wide and made a crater about a mile across and about 400 feet deep. So something around about 50 to 100 meters across is what they call a city killer. If something like that were to hit Washington, London, New York, Paris, whatever, that's it. Those cities would no longer exist. There's a fantastic piece of software you can try online called the Impact Modeling Kit, I think it's called. It was run by, I think, Cardiff University, University of Glamorgan, etc. But it's a really neat piece of software that lets you build your own impactor, set the velocity, set the impact angle, all sorts of conditions as to what it's hit, if it's in the ocean, if it's in sedimentary rock, igneous rock, etc., etc. Really, really good. And you can see just how much damage would be caused, not only by the crater, but also the secondary shock effects. So the idea with the DART mission, this 600-ish kilogram spacecraft, no scientific instruments on board at all. It was literally navigation cameras based upon some of the work that was done on the New Horizons spacecraft. So this is proven sophisticated technology run out of NASA and Johns Hopkins University. So combined effort. Johns Hopkins have been doing amazing work. Obviously they did phenomenal work on COVID. So it's not just that, they, scientifically they are one of the best in the world. Their team basically were then monitoring the impact, and what you've got is you've got an impactor, as I said, at around about 12,000 miles an hour, and they're looking at the minutest level of change in the orbit, and they think it's literally it's in the millimeters kind of per day, as it will, or less than that. But what they're going to be able to do from the Earth now, we've got the images from the James Webb, got the images from the Hubble and from the Atlas observatory on the Earth, even down to friends of mine in Italy were imaging it using robotic 60-centimeter telescopes out of South America while it was happening. So this was something that could be seen even by amateurs from the Earth. But what the bigger telescopes are now going to be able to do is monitor the orbital change between Dimorphos and Didymos, which is this kind of 2 asteroid system, and to see just what the impact did. Now, it's not just the impact, it's also the ejector. You're basically creating a kind of gas plume coming off it. So this ejector plume coming off is also going to give it a push. So on top of that, it's really interesting as well, looking at the kind of mission profile. If it had missed, and it didn't, if you watch the videos, I mean, it was literally, as I said, you're hitting something only 160 meters wide, traveling at 12,000 miles an hour, 7 million miles away after nearly a year in space. It's incredible orbital dynamics and navigation capabilities anyway. But on top of that, if they had a miss, they've got ion thrusters they had ion thrusters until it blew up on the DART spacecraft itself that basically could have allowed it to swing by again and do another attempt 2 years down the line. Thankfully, they didn't need to do that. But I mean, I don't know what you think, Terry. It's just, we're looking at some of the videos there from the James Webb. I mean, it's just,
I think everybody was surprised.
Stuff. Yeah.
It was a far bigger impact event in terms of ejecta than anybody expected at all. And I mean, it wasn't just that the kinetic energy of the spacecraft of that mass traveling at that speed, it was basically an explosion when it hit, because everything just sort of disintegrated, a bit like an asteroid impact on Earth. It's not just that so many millions of tons hit the Earth, that it literally becomes an explosion whenever it hits solid ground or the water. So the ejecta being thrown off then adds to the energy, as well as the actual sort of the snooker ball effect of one object hitting another one. But what amazed me on the way in was that they do call it a rubble pile, but I was sure I could see areas that looked like a surface, where you could see rocks sitting on a surface. Now, that's a very amateurish interpretation. It might have been a big sort of slab of rock on which other rocks were sitting, but there is an area in some of the close-up pictures where it looks as if there is a surface with all those rocks sitting on it. But that remains to be seen, interpreted by experts far more competent than I am. And when they hear of probe gets there and takes much more detailed imaging.
Well, that's the issue, in that the definition of rubble pile, because they're still waiting, and it's going to be several months now of observations to really work out what the impact, pardon the pun, of this mission was. You look at the dust layers, condensed and compacted dust layers, where you've got rocks sitting, and don't forget the gravitational field of this is minuscule.
Yep.
I mean, if you hit something with that kind of energy, you're going to be throwing rocks off into wherever. They're just going to be flying off in all directions at all different velocities, etc. So it is, and the gravitational attraction of that asteroid system is not going to be sufficient to bring them back. So you are already creating more nominal space debris along that orbital path, as it were. And some of the rocks, as you said, you look at the images as it was coming in, you had rocks the size of buses. on something 163 meters wide and much larger in some cases, those would have all been, if that had hit at the right angle with the right impact velocity, those would have been thrown off into space, never to be seen again. So it's going to be fascinating to see comparison images between what they saw during the last few minutes during the approach, the last few seconds, in fact, during the approach, and what the Hera spacecraft sees in, hopefully 4 years' time. I don't know what they're going to see. The issue is that I always think, well, yeah, this is fantastic. And if you've got enough time, we've got Apophis and various other asteroids, which, are near Earth asteroids that potentially, according to the Torino scale, which is a kind of scale where you measure the threat of an object hitting the Earth. And statistics say, would you a medium-sized impact every so many thousand years? But then obviously we had Tunguska in 1908, which was a significant impact that would have wiped out a city had it hit a city. We had Chelyabinsk only a few years ago. We had Sakhalin in the mid-1940s, late 1940s, again over Russia. Quite significant meteorite impacts there. Again, thankfully with Sakhalin, hit the Ural Mountains, didn't really cause much damage. But the statistics are one thing. The reality is we just don't know. And the thing is, asteroids, great. If we know the orbit of an asteroid and we've got, say, 30 or 40 years to knock it by that few millimeters that are needed to knock it out of orbit so that it doesn't impact the Earth, great. But the reality is, as shown in the movie Don't Look Up and shown in Armageddon and shown in Deep Impact, the potential for a cometary impact, we've got no time at all. We've got literally less than a year between the time it crosses the ice line near Jupiter and the time it could potentially intersect with the Earth. So I'm seeing in the chat, Chris, thanks again for brilliant comments. Yeah, APL do go under the radar. Absolutely. JPL, NASA's Jet Propulsion Laboratory, tend to get a lot of the kind of kudos for this, but NASA's a big organization and there's a lot of different sectors there. COTS missions, common off-the-shelf technology, yes, absolutely, using essentially like stuff that you could buy at any electronics store in some cases. But he's also made a good point in the chat there. We'll be sending a Starship to deflect it, and you're not far wrong there, Chris, because the reality is this is only 163 meters wide and the nudge on it is tiny, is minuscule. If we're looking at a much larger body coming in at a very high velocity, and don't forget we're now detecting extrasolar asteroids, Umamamama, pardon my pronunciation of its name, that thing was moving some. These are moving at way faster velocities than anything we're encountering in the solar system, because they're extrasolar, they're extrasolar objects coming up from different star systems potentially and traveling in at astonishing rates. Even things like Hale-Bopp, etc., you're looking at 180 to 250,000 miles an hour for cometary objects. Now, there's nothing we could do to stop that. Absolutely nothing. And Starship, I've been saying this for a long time, taking something the size of a Saturn V, being able to, now that, Starship's a good example of something that can land autonomously on another surface. Starship's going to be one of the ways that we're going to get to the moon over the coming years, potentially. That's going to be interesting to see the exhaust plume from that when it lands on the lunar surface. But if you could strap or attach something the size of Starship via anchors, hooks, whatever, to an object heading our way, and then have enough propellant on board, either via refuel or actually on board, to do a burn, to deflect it in that way, because I don't think an impact to burn is going to probably do the job. It's more than likely going to turn a bullet into a shotgun, as it were, and we'll just get hit by thousands of large asteroids rather than one gigantic one, which will be equally as catastrophic in terms of the Earth. I don't know what you think, Terry, but to my mind, that is something that we really need to be thinking about now long term.
Absolutely. If something that size is heading our way, it will concentrate the minds wonderfully, as they say. And nothing is ruled out then. You can go nuke, you can go Artemis, you can go whatever, the biggest rockets we have available, because it's basically the future of civilizations at stake. And it's all hands to the pumps in a situation like that. And I know there's the nuclear space treaty and all the rest of it, but, if half a continent's going to be wiped out, we're not going to worry too much about that. So
there's an issue with conventional nukes. So in terms of the range, like the Minuteman missiles, etc., you're only looking at half the distance to the moon. You're too late at that point. You are looking at basically nuking up a Starship, or something along that line. But anyway, all good.
But anyway, so far so good. I mean,
Yeah.
they're expecting within the next week or so to get a rough idea of how much the orbit has been changed, but probably a couple of months before they can get really accurate measurements. The longer the time period they have to measure it, the more accurate it gets.
Oh yeah, absolutely. I mean, you've done loads of orbital calculations on comets and asteroids in the past, and once you've detected something new, it's having that longer arc, where you can basically measure the orbit and get a much more refined and detailed picture of the orbit, which is the one thing that they did get wrong in the movie Don't Look Up, where they basically said, well, this is going to hit the Earth within about an hour of detecting it. It's like, your orbital arc's not going to be that good. But anyway, moving on, it's an absolutely amazing feat, and you've got to doff your hat to APL, John Hopkins, the whole NASA team, the Italians as well. Putting a CubeSat. I mean, this is technology that's that big, as it were. I mean, the CubeSat that they use, Lycia Cube, is literally about the size of a small drawer that you pull out of a top shelf kind of cupboard, as it were. It's amazing what they did with that. But anyway, what's next, Terry? This is a good one.
One of my favorite objects, and one of your friends' favorite objects too, Enceladus, one of the fascinating moons of Saturn. It's not the biggest by any means, diameter about 500 kilometers. It orbits at a distance of about 238,000 kilometers from Saturn in a period of about 1.4 days, just visible in a good telescope. It'll be getting easier to see over the next couple of years as Saturn's rings turn edgewise to the Earth, and therefore the bright light from the rings is minimized. I saw it myself back in '66 for the first time, but I haven't seen it very much since, mainly because the rings have been, certainly the last 10 years or so, have been pretty well open in terms of their angle presented to the Earth, and so they're very bright. That means that any satellites that are close into the rings are quite hard to see. Anyway, it is a fascinating object. It is absolutely covered in ice. The amazing thing is that they are pretty sure, 99.9% sure, that there is an ocean underneath that ice, liquid water. We don't know just how thick the ice is. It probably varies according to locations and so on. There's all sorts of flexure effects going on. And there are these famous tiger stripes that appear on the surface, which show that the surface of the ice is in motion. It flexes, it cracks, it closes up again, refreezes, and so on. And where you have water, there is always the possibility of life. And the very fact that the water is liquid shows that the temperature can't be too low, although it's obviously under a certain amount of pressure because of all the weight of the ice above it. But there's been a considerable speculation ever since we discovered this liquid ocean under the ice that there could be life there on Enceladus in that water. Now, the interesting thing about Enceladus is that because of the flexure effects of the gravity as it orbits in a slightly elliptical orbit around Saturn, you get geysers of material spurting out through cracks in the ice. And the Cassini spacecraft has flown through some of these. It's with us no more, unfortunately, but another very, very successful mission studied Saturn and all its moons in considerable detail. So they knew, obviously, that Enceladus was so interesting. They flew the spacecraft through these plumes and sampled them. And they found a whole lot of interesting stuff, organic stuff, methane, oxygen, nitrogen, and so on. But they didn't find an element that is essential for any advanced form of life called phosphorus. And that was a bit disappointing. Phosphorus is absolutely essential certainly for our life. It bonds basically the four nucleobases, adenine, cytosine, thymine, and guanine, to the helix of the famous DNA double helix. And also, if you ever did any basic biology in school, you'll have heard of ADP, adenine triphosphate, which is what it says on the tin, phosphorus in that as well. That's basically the molecule that does all the energy transfer around the reactions in the human body that enables muscles to work and organs to function and so on. So phosphorus is absolutely essential for any advanced form of life, probably even any sort of cellular life. It plays a role in cell walls and so on. So they were a little bit disappointed that there was no sign of phosphorus, but now they're fairly sure that there is phosphorus there. They have remodeled what they think is basically the morphology, if you like, of the ocean, the rocks under the surface of the ocean, and they're pretty sure now that there are mechanisms in which phosphates will come off the rocks and be dissolved in the water. As I say, it's not proof. It's just a new theory, which seems to be fairly widely accepted. If there's phosphorus there, add that to all the other essential elements and organic molecules and compounds that we have, and the chances for life on Enceladus go way up. We'll not know for certain until another spacecraft can go there and take actual samples. There are long-term plans to land something and actually drill down through the ice into the water. That'll be a subject for another day, but it's certainly looking an awful lot more hopeful. So yet another one of the essential elements for life discovered on Enceladus, possibly on Europa too, we don't know, but Enceladus is the one that's in the news at the moment. So fascinating stuff, Nick. I'm sure you have your own thoughts on it.
It is, and just breaking news that came out, totally unrelated to this, but in a way similar. I've just seen that Heidi Hammell's announced that the Hubble, they believe, has now detected ozone in the moons of Uranus. So they're looking for James Webb backup on that. That's come out in the last hour. Going back to this one, I don't know if anyone watching in the audience or listening watched Frozen Planet. They were talking about some of the stromatolites. So stromatolites are some of the most ancient life forms. It's kind of like, it's a micro cyanobacteria, kind of almost looks like a rock. And they found examples of these off the coast of Australia. There's fossilized examples, and they believe that some of the earliest life forms were these stromatolites. You can look them up, and I'm not a kind of biologist, planetary biologist by any stretch of the imagination. But one of the interesting things that came out was looking at some of the lakes in some of the most inhospitable regions on Earth, like the Antarctic, Arctic regions, etc. And they were finding these stromatolites deep below the surface where there's no sunlight. They're literally basically living on sulfur, cyanobacteria, sulfate reducing bacteria, etc. It's just incredible watching these things kind of form and what they are. They, like I said, they just look like rocks, but they are a living organism. Even something as basic as that, if we were to detect that on, say, Europa or Enceladus, or potentially on one of the moons of Uranus. The thing with Enceladus, as you said, Michelle Doherty and some of the team that were working on the Cassini mission, some of the observations that they and others were doing, that when they flew the spacecraft essentially through these plumes that were coming off Enceladus, they didn't quite have the instrumentation to really be able to detect what they really wanted to be able to detect. Now, if you're looking for life, because it wasn't really a consideration. You're orbiting Saturn, you're looking at what Saturn's doing, and obviously Titan was a key consideration in that, but more kind of getting through the cloud deck, looking at what was in with the Huygens lander. Enceladus has now become a really hot topic in terms of, is this one of the key points in the solar system, along with Mars? And there's new evidence now of Mars, subsurface water on Mars being kind of brought into the fore again. We could have talked about that during tonight's show, but we've done Mars so many times we thought we'd kind of do something a little bit different. But we've potentially now got Europa, Enceladus, and Mars in our own solar system. And there's all sorts of hokey theories about the atmosphere of Venus. I'm not a big buyer on that one. There was all big brouhaha about a year ago about what we've detected and phosphine levels, etc., in the upper atmosphere of Venus. Doesn't really float my boat, that one. It's a little bit too tricky. And then people talking about orbiting Venus and using it as a kind of better way to train astronauts in Mars. But anyway, Enceladus, Europa, Mars. Now we've got 3 potential life-bearing points in the solar system. And could you imagine if we found life on all 3? Even if it was microbacterial subsurface on Mars, if it was stromatolite kind of life on, on Enceladus and Europa, all bets are off.
Yeah,
it's that simple, but it's a stunning thing to look at. And if you do ever get a chance with a telescope to look at Saturn, as Terry said, the rings now are starting to close up, and over the next few years they're going to get thinner and thinner until they're literally just a thin line across across the disk, as it were, of Saturn. I've only seen Enceladus once, and that was mostly through a telescope as well. Obviously through a telescope, but imaging through a telescope, and being able to see it and just imagining what could be there. As you said, the tiger stripes, the ice, the plumes now ejecting from it. It's fascinating. It really is fascinating.
And then there's Titan as well, with a methane atmosphere, be different biology, but certainly not. You couldn't rule out the possibility of life on Titan as well.
You couldn't, and especially, in a few billion years when our sun suddenly starts to kind of wake up a little bit more and grows and swallows up Mercury and swallows up Venus and decimates all life on Earth. Titan's going to become quite a nice little hotspot for summer holiday vacation, I would imagine. But there we go. Anyway, moving on. Next one. This is a bit more, I don't know, a bit closer to home. We were talking about Mars a little bit, but it's kind of come even closer to home. So European Space Agency have had a pretty torrid time of it in the last few years, because obviously they had a key relationship with Roscosmos, the Russian space agency, and after the impact of what's happening in Ukraine, obviously it's terrible what's happening there, full stop, and it's potentially escalating as well at the moment, and it's all getting a bit horrible. But the scientific impact from our perspective, that's what we're going to talk about, is the science impact, has been quite catastrophic for a lot of missions, as it were, in particular European Space Agency. So initially they were going to launch the ExoMars mission a few years ago using the Roscosmos Proton rocket and the Kazachok lander. That all got scrapped, got bumped because they had problems with the parachutes a few years ago. It was due for launch this year. That's now been obviously put on hold, well, completely killed, courtesy of the Ukraine invasion, and nobody really wanted to work with Russia anymore. So ExoMars, Rosalind Franklin as it's now known, will be launching, but in a few years' time. Still going to Mars, still going to be hunting for the potential for life on the surface of Mars. But the other part of this mission, or the kind of double prong, as it were, in this mission, was you've already got Perseverance on the surface, which is picking up Martian samples, caching them, putting them into cache tubes, etc. And then the original plan was to send down another lander that was going to act as kind of like a launch base for a MAV, a Mars Ascent Vehicle. And then the European Space Agency were going to send their SFR, their Sample and Fetch rover, which was a smaller, kind of quicker, more nimble rover, onto the Martian surface. That was going to pick up the cache samples, bring them back. Now it looks like Perseverance, with its nuclear power RTG, should be able to get those samples back to the MAV, as it were. And if not, they've got now experience with helicopters on Mars. So that kind of left the European Space Agency in a bit of a lurch, as the SFR mission really wasn't needed. There was all sorts of rethinking of proposals based upon this lack of tie-in with Roscosmos and how much capability and the cadence, the time when you could actually do these launches. Obviously, the distances between Earth and Mars, you've really only got an opportunity every 2 years or so to do an effective launch due to transfer distances, etc. So the SFR, the Sample Fetch rover, also known as a NON, not QAnon, is having to be repurposed. Now, this thing's currently sitting in a quarry in Milton Keynes. So if you don't know Milton Keynes is one of these new towns in the UK. It's not known for its dynamism, shall we say. It's based upon a US model of vertical and horizontal roads, but it is home to the Open University, and the Open University do an awful lot in terms of planetary science, really great planetary science. So Airbus, who are the prime contractor behind this big defence company, they've obviously worked on the ExoMars rover as well, and they're quite happy that that's still going to get a shot. Obviously somewhat delayed, but the Sample Fetch rover, now they're repurposing and they're thinking of putting it onto the surface of the moon. Now, based upon the fact that Artemis, all being well, will launch soon and will go into lunar orbit and will prove the technologies, and then the next mission will be an Apollo 8 style crewed mission where they're going to do the orbiting the moon, etc., and send astronauts. And then the third mission, effectively, they're going to then try and land on the moon. The question begs, why? Why do we need, if we're going to have boots on the ground potentially back on the lunar surface within the next 4 to 6 years, say, at the outset, let's say 6 years at the outset, why do we need to send another rover? I mean, the arguments are, potentially, Terry and I were talking about this before, and Terry said, yeah, you could use it for kind of go fetch, as it were, and picking up stuff. But you only have to look at the lunar rovers from the Apollo era, and those guys covered more distance in 2 or 3 days than every single rover on Mars has done in years. I mean, they can literally nip that. And if you've got boots on the ground and you've got real scientists, real geologists, etc., they're the ones who are going to be able to spot things, pick things up, say, "Ooh, what's that?" rather than have to navigate and negotiate. And don't forget, the lunar rover technology, which is over 50 years old, is proven technology. It worked. It just worked. They strapped it onto the side of the lunar module. It unfolded. They got 2 astronauts in it. They went around collecting hundreds of kilograms of lunar material, which is still being scientifically analysed to this day. This thing's going to be trundling on 4 wheels in some of the harshest, most nasty, horrible stuff imaginable. Lunar regolith is hideous. It's absolutely hideous. Gene Cernan, who I knew really well, and various other Apollo astronauts said it would take them weeks to get this stuff out of their fingernails and their fingers. It's like tiny little microscopic shards of glass embedding itself into you. And if you think about the difficulties NASA have had with Mars, with the trashing of the wheels on the previous rovers, you only have to look at some of the damage images from the wheels, and the fact that the Martian surface, apart from the sand traps, which obviously, Opportunity and Spirit, encountered many of those, and the demise of one was as a result of those sand traps. The Martian surface tends to be a lot more robust than the lunar surface. The lunar surface is just caked in this horrible regolith due to thousands of years of no atmospheric protection. You've got constant bombardments, etc. And that's the other thing. The SFR was designed for Mars, which has a very thin atmosphere, but it does have an atmosphere. It also has a different day cycle. It's got a sol, which is approximately, give or take, the same time as the day is on Earth. Whereas on the moon, you've got potentially 14 days of no light at all, absolute ridiculous freezing temperatures, no atmospheric protection, changes in radiation levels, etc. It's not going to be an easy job to do this. So when they were saying, "Oh, we're going to repurpose it for the moon," and everyone was going, "Oh yeah, isn't that great?" Well, yeah, isn't that great? It's going to be really difficult. I don't know what your thoughts are, Terry. But
Yeah, in the long term, certainly, when there's a permanent personed crew to base on the moon, something like that, I think, will be redundant. But the first landing missions on the moon will not be staying for more than, I don't know, off the top of my head, a month, possibly only 2 weeks, i.e. a lunar day. Whereas they'll go and they'll come back, and maybe there'll be a period when there's nothing happening there, and then there'll be another crew launch and so on. Something like that in that initial phase could be there working autonomously. Because it'll take, I would imagine, a number of years before you get a lunar base built where people can live permanently. And during that period, something like that could have a role. But as you say, once you get the boots on the ground, or the bums on the seats, basically, on the sort of rover that they'll have there, and they don't have to use a camera to sort of interpret the track up ahead of them. They drove around as fast as those things were capable of going.
Yep.
And probably faster than they were supposed to be going.
Yeah, just like Charlie Duke. Yeah.
They can look up ahead and see, there's a boulder, right? We just go round that,
They were taking off on the lunar surface.
They did. They went, yeah, I know. So when you have people there permanently, then and rovers that they can ride in, and if you've seen lots of stuff, I'm sure, on the internet about the various designs that there are for those, absolute luxury compared with some of the ones that the Apollo ones had, then a small thing like that has to be programmed and has to navigate itself and is limited in what it can do, probably not much of a role for it. But in the meantime, during the building of a lunar base, there may well be a role for something like that.
The problem is it's only got a very small robotic arm, and it's only designed to pick up very small cache samples. So it's not just refactoring the rover, and obviously the wheel design is going to have to be completely redone. The dust protection is going to have to be completely redone. The camera systems, everything that was designed for light levels on the Martian surface, that was designed for radiation levels on the Martian surface, which are fundamentally different, and the temperature variance, obviously, on the Martian surface compared to the lunar surface, all of that's going to have to be redone in short shrift, as it were. And then you've only got, like I said, I'm watching a video of it now, and it picking up a sample on the surface of Mars. It's a really puny little robotic arm, relatively, compared to, as you said, people like Charlie Duke, John Young, Gene Cernan, Jack Schmitt, trundling around between, Dave Scott and Jim Irwin on Apollo 15, 16, and 17, trundling around and just going, wow, orange soil, let's go over there and have a look and dig some up, and incredible discoveries. So the viability of it in its current form, I think, is quite limited in terms of what it's going to be able to do. The cost of refactoring it, rebuilding it against the potential scientific return, because don't forget, it hasn't got much in the way of scientific instrumentation either. It was designed to go
just
fetch,
to pick up,
pick up stuff. So the scientific return on this is going to be minimal as it stands, unless you get, large investment. With the current economic situation, especially in the UK, the investment into science, yes, it's really important, but are people going to be able to, in their minds, justify that to a government minister? And don't forget who's now in charge of space in the UK. It's none other than Jacob Rees-Mogg, who's not exactly known for his forward modern thinking, shall we say. He's now in charge of BEIS, which basically run the UK space sector, as it were. They're the business and energy industry sector. They control the UK Space Agency, or they're kind of the overlords, as it were. It's going to be interesting, and to my mind, it's like ESA, and Airbus. You can appreciate that Airbus have been working on this for a long time. They've got some amazing engineers who've been working on this for a number of years. The question is it really worth going along this line? Maybe, if you wanted to have a rover, as you said, to go fetch around a permanent lunar base, and you didn't want to risk astronauts going out all the time, potentially, if you wanted to say, oh, there's a rock over there, let's go and pick it up and see what it is. But who knows? I'm not a big fan.
Yeah, there could be periods, for example, with the intense solar storms, when you want something done outside, you can't send astronauts outside. So
that's the issue with this rover as well, is that
it needs to be hardened enough.
Don't forget the orbit of Mars compared to the orbit of the Moon. You are 30 to 60 million miles further away. So the incident radiation and the fact that you've got a level, okay, it's minimal, but a level of atmospheric protection and a day-night cycle that's in the 24, 25-hour region, it's it's going to be interesting. Great quote in the chat from Chris. Tell Jacob Rees-Mogg it's going to work in imperial measurements.
He beat me to it. I was just going to say, if we change over to pounds, feet, inches, gallons, or whatever, just make sure that everybody does it, not a mixture.
Well, as we know from one of the previous Mars missions, where there was a kind of bit of mix-up, and that hit the planet rather hard. Let's see what happens. I wish Airbus all the best. I mean, they can't test it in the Mars yard. They're testing it out, like I said, in a quarry in Milton Keynes, which is probably the most fun Milton Keynes has seen in a long time. Let's see what happens. But moving on, this story, Terry always finds the best stories. He finds crackers. This one is peachy.
Indeed. Back to our old friend Einstein again, relativity and gravitational lensing. You have probably seen some amazing photos of incredibly distant objects that have been imaged even before James Webb, but telescopes on Earth and indeed the Hubble Space Telescope using the effect of gravitational lensing. And basically what happens is, if you have a dense clump of matter way out in the universe, either a single galaxy or more likely a galaxy cluster, the light from anything beyond that will be gravitationally bent as it passes the cluster. And that can act as a sort of a lens, not a perfect lens, or rather distorting lens, but nevertheless acts as a lens. And that focuses the light from an object which is even further away and allows us to see it here on Earth. And that is how we have detected some of the most distant galaxies in the universe. Now, the light that comes from the more distant object can pass along a number of different pathways as it travels through or around the edge of the cluster, because a galaxy cluster is not homogeneous. There's big galaxies, small galaxies, and they're distributed more or less at random in the cluster. So the gravitational field of such a cluster is quite complex. That means that the light from the distant object beyond can take numerous pathways before it actually reaches the Earth. And of course, the speed of light is finite. So the longer the pathway that light takes, the longer it's going to take to get here. And what has just happened is that they have been able to measure and detect and photograph the light from a distant object, which took five, I think, different pathways through this galaxy cluster. And the light from this more distant object was delayed by a total of 6.73 years between the earliest set of photons to arrive from the distant object and the latest ones. And they imaged it, measured it over a period of 14 years. So basically, you have supermassive black holes are probably the objects that we're talking about at the centers of the massive galaxies. And they obviously have a very, very intense gravitational field. So what was occurring to me is not only is that really cool in that you're seeing the same object at, in this case, over 6 different years in terms of its evolution, you could possibly use that to detect different versions of or different stages in cataclysmic and fascinating events like supernova explosions or gamma ray bursts or fast radio bursts, things like that. If you detect one that has come from near a galaxy cluster or supercluster on its way here, you can then look and see if there's some other images that arrive later and look out for them. And you maybe see, just to take one example, supernova from the very start of the explosion and be able to analyze things. Normally, when we see a supernova, it's already near the maximum of its outburst because that's how you detect them. We think we know what happens during the stages of a supernova explosion, but we've never actually measured all of them. So there may be ways of using this technique, sort of a time travel, to say, right, a supernova has just gone off in that area there. It's behind a galaxy cluster, which could act as as a gravitational lens. We look and see if we can detect other images of that supernova explosion occurring within the next couple of years, because their light is taking a longer pathway to get to the Earth. And if we can detect them, we'll get the supernova explosion right from the start, the same with the gamma ray burst or whatever. But it's just so really cool that Einstein is basically right yet again. And the idea of seeing an object, like if I'm looking at you, I see you as you are now. There's no way I can see you as you also were 6 years ago. The whole concept is just absolutely fascinating. So Einstein just he continues to amaze, but there's real science potential in this as well.
It is amazing as well. And you talk about supernovas. Obviously, with supernovas, you've got, as you said, Terry, light has a finite speed, and anything between us and the supernova could potentially slow that down and or deflect it, etc. But then you've got the neutrino bursts associated with supernova, where typically when a supernova goes off, now with the accuracy of the neutrino detectors and the ability to triangulate, they can almost say, well, the supernova has gone off, and within a few hours you start to see the first light from it. So neutrino detectors over the coming years will play, I would imagine, quite a major part in this. If you've got the James Webb, you've got the Hubble Space Telescope, and you've got Earth-based telescopes like ELT, and you've got neutrino detectors, being able to say, right, we know that there's a supernova going to kick off in the next few hours because we've got a neutrino burst coming from this area of the sky. If you are then able to accurately, using wide field survey telescopes, start to see the light from the supernova, then you can retask the Hubble and the James Webb to look at the spectroscopy of the supernova. And then, as you said, if it's behind a gravitational lens, getting a second showing, almost watching it on catch up, as it were, seeing it happen again and again. The other beauty of gravitational lenses is it's a lens. So if you've got objects at the far distant edges of the observable universe, and James Webb is already proving Hubble, not redundant, obviously, but it's doing what the Hubble used to take weeks to do in hours in terms of imaging some of the most distant objects ever imaged, with redshift values that are blowing everyone's mind because galaxies shouldn't form that quickly, etc. But if you then detected a gravitational lens at those kind of redshifts, could you imagine if something were behind it, that you could say, well, we've got a huge Z number gravitational, a galaxy cluster, which is acting as a gravitational lens, and then something happens beyond that. It's going to throw. I mean, it was really interesting. I was reading the Guardian this week, and quite a notable astrophysicist said he was so fed up of having to kind of kowtow to the dark energy, dark matter thing, which he said is, it's just kludge numbers. It's a kludge factor. We don't know. We really don't. He and many other astronomers do not think it's a reality. They don't think that dark matter, dark energy is a real thing. It's just a kludge factor. But the fact is that they can't say this out loud, or they can't publish papers because the peer review system will shut them down. And this was, like I said, it was either the Observer or the Guardian the last few days. You can read it in the letters column. But the James Webb is fundamentally changing our understanding of galaxy formation at the earliest epochs of the observable universe, as it were. And to be able to see something like this, and don't forget, this is now being detected by AI engines. So there's a lot of talk in the news about AI and artificial intelligence and how it's been used for nefarious means, like, being able to look at people in rogue nation states, as it were, using CCTV cameras and identify if they're criminal. There's all sorts of bad things happening with AI, and how it's able to get however many thousand data points on an individual, and then use an AI engine to feed you things that make you spend more money or whatever. But AI has got some phenomenal positives to it, and this is one of them. The AI engine that was used on this, much like Galaxy Zoo, if anyone in the audience knows or has taken part in the Galaxy Zoo project, the Zooniverse, incredible, where they got several 100,000 amateurs, ranging from school teachers, kids, whatever, to classify galaxies, just taking images that they were shown on a web browser and say, that's a spiral galaxy, that's elliptical, whatever. And that trained these AI engines and trained, computers to understand what they were looking at. And again, the AI engines are now picking up these gravitational lens events, as it were, all over the universe. Now, once we've got the James Webb and the Hubble are phenomenal instruments, but they're very, very narrow field of view. The equivalent field of view is if you hold your arm out at your arm's length, the tip of your little finger is roughly the imaging field of view of both of these telescopes. It is quite small. It's not huge, slightly larger for the James Webb, but the Hubble, you were talking postage stamp size, as it were. The Hubble Ultra Deep Field, that was the size of a postage stamp. It's a tiny little portion of the sky. Once we've got the wider field telescopes on Earth that are able to image down to equivalent magnitudes that what the Hubble is able to achieve now. Obviously, the James Webb is a different thing because you're in the infrared end of the spectrum. You can't really do that from the Earth's surface, but it's going to be incredible. It's going to be absolutely mind-blowing to watch what's coming. And I would say all bets are off that in the next 10 to 15 years, there will be discoveries made by the James Webb that are going to throw into absolute turmoil everything we understand and know about the earliest parts of the universe, galaxy formation, etc., etc. That's just what I think. I could be wrong, but it's really wonderful to see. Again, and this is Hubble data. As you said, 14 years between various ground-based telescopes and the Hubble, etc. Being able to take this level of image detail. But it'd be great to see something happen and then, let's watch it again in a few hours. Let's watch it again in a few years. Amazing.
You're right about the gravitational lens, the neutrinos. The only thing is, at the moment, the triangulation isn't accurate enough to say exactly where we're going to get. We get a lot more neutrino detectors that will improve that. But the principle is right. Yeah, the supernova in 1987A was first detected by the neutrinos arriving first.
Well, again, that'd be a great way to utilize the moon and the Martian surface. If you were to build gigantic water tanks, because essentially a neutrino detector is a load of photosensors in pure, like very, very pure water, and essentially when a neutrino passes through it, you get this Cherenkov radiation, you get this light effect that can be picked up by very, very sensitive photo detectors that are based on them. What they typically do on the Earth is they stick them inside very deep mines and caves to shield it from a lot of the neutrinos coming from the sun, etc. But if you've got a massive triangulation region where just be amazing.
Wait till the Vera C. Rubin telescope starts pumping in petabytes of data.
Well, if Elon Musk doesn't trash the sky better, made it literally inoperable because you can't see through all that junk that he's put up there. Anyway, that's another rant on another day. Moving on to our final bit of the show, which is our look-up section. What's blown my mind, and Terry's going to talk a lot more about this, but I'm just going to quickly mention Jupiter right now is glorious, is absolutely stunning to see. Even with a small pair of binoculars, you can see the moons quite clearly. And when you say small, average size pair of binoculars, you can see the 4 major moons of Jupiter. However, if you've got time, have a Google for Ian Sharp and Damien Peach. Ian Sharp and Damien Peach are 2 of the best planetary imagers around there. Christopher Go as well out in the Philippines, really, really good, known for years of contributing real science to some of the Jovian and Saturnian images coming from NASA. So Damien and Ian typically have when Jupiter's at opposition and close opposition, they have a holiday in Barbados. Barbados has got some of the best laminar flow and seeing conditions pretty much anywhere. Outside of the major observatory sites like Paranal, etc. So what they do is they take two 14-inch Schmidt-Cassegrain telescopes, Celestrons, SCTs, some whatever camera they're using this week, used to be Luminaires, they're obviously moving on. The images that they're coming out with are absolutely mind-blowing. I mean, they're not Hubble. People say, oh, it's as good as Hubble. It's not, but they are stunning, considering these are amateur astronomers with amateur equipment being able to image detailed features on the clouds of Jupiter is remarkable. But for my mind, what's even more remarkable is they're getting so much detail now on the surfaces of the moons. So Ganymede, Callisto, Europa, and Io. And I had a bet with Damien about 10 years ago to say, I think Damien or Ian will probably be the first people, amateurs, to image a volcanic eruption on the surface of Io. If it's big enough and bright enough, and they've got the telescope pointing in the right place at the right time, I think they could see it. I don't know what you think, Terry, but Jupiter's stunning at the moment.
Yeah, absolutely. You may have read a bit, or certainly seen on social media, about Jupiter being the closest and brightest it's been for about 60 years. I mean, that is true. It's a wee bit like the supermoon effect. It's there if you know to look for it. But actually, the distance of Jupiter from the Sun varies between 741 million kilometers and 816 million kilometers. So it's significant, but it's not huge. It just so happens that at the moment, Jupiter is pretty near its closest position to the Sun. And when Earth is at opposition, then it's at its closest to Jupiter. So that's why it is so bright at the moment. But yeah, absolutely fascinating. And I spent more hours than I could care to count up observing Jupiter back in the days when visual observing was actually better than photography. But that's another story. Anyway, it's just past its very best at the moment. Still fabulous. The brightest object in the sky at night, apart from the moon. You really can't miss it. And it will be getting better higher up over the next couple of years, although just not quite so bright. Just in case, before I forget, if anybody looks at that image in the background and says, those aren't meteors. Yes, we know they're not meteors. Those are star trails. It's just a nice photographic effect. You can do that sort of thing yourself, actually, just to open the camera. Well, now you're talking about digital cameras, but basically take a whole series of exposures and stack them. And what they've done there is sort of increase the aperture or increase the exposure time so that the images get brighter towards the end. So it looks as if it's very faint at the start and then becomes brighter at the end. It's not trick photography, but it's not just...
It's art.
Yeah, it's art. So we know those aren't meteors. Anyway, we're talking about the Draconids. Now, this could be sort of a damp squib, or it could be something that's quite spectacular. Draco is a constellation up in the northern part of the sky, and meteor showers are normally called after the constellation from which they seem to appear. These ones are sometimes called the Giacobinids because they come from a comet called Giacobini-Zinner. Normally, it's a very minor shower, perhaps 5 per hour, but just checking my dates, in 1933 and in 1946, there were major outbursts where people were seeing about 1,000 per hour. Now, there's absolutely no indication that that's likely to happen this year. It's basically over the next couple of nights, which is why we're talking about it. But it's always worth having a look at any meteor shower because they can produce outbursts of much higher activity than normal. So Draco is a very faint, straggling constellation. The best way to find out where the radiant is to look for the summer triangle, which most people will know of. Deneb, Altair, and Vega. And if you take the line from Altair to Vega and extend it on the straight line past Vega for about 2/3 of its length, that will take you to the head of the constellation of Draco. And that is roughly where the meteors will appear to come. Of course, they appear anywhere in the sky, but if you trace their paths back, they should all intersect at roughly that part of the sky. We also have another shower coming up on October the 22nd, the Orionids. although they're in Orion, they actually look as if they're slightly closer to the feet of Gemini. They're right up in the top left corner of constellation of Orion, up beyond Betelgeuse. Same effect again. The meteors will appear to come from that part of the sky, although they can appear anywhere in the sky. The Orionids are slightly better in terms of the average number of meteors you see each year, maybe 15, 20 per hour in a really dark sky. In the case of both these showers, the moon isn't too much of a problem. For the Draconids, it's a small growing crescent, a waxing crescent. For the Orionids, it's a relatively small waning crescent, so it doesn't come up until late in the night, and it's not too bright. And finally, one thing that occurs on the very morning of our next show, which will be on October the 25th, a partial solar eclipse. It's not a huge one. It varies where you are in terms of the country. It'll only be about 16% eclipsed at Land's End. That goes up to about 35% if you're up at John O'Groats. We're not going to say too much detail here. We haven't time, except the very important warning: never look at the sun with any sort of optical equipment at all. Don't even stare at it with the naked eye. There are all sorts of guides available online on how to observe it safely, or go to your local astronomy club. They'll probably be doing some sort of an observation of that. So that's coming up on the morning of our next show. So I'm sure you have thoughts on what else you can say.
Yeah, I mean, firstly, we are back October the 25th. We've slight change in schedule coming up over the coming months because of personal clashes and all sorts of things. Terry's one of the busiest people imaginable, so we're kind of bumping the shows around. So we'll give you plenty of warning. Obviously, Space Store. Keep following Space Store on Twitter, YouTube, etc. They'll be able to tell you about upcoming shows. Reinforcing what Terry said, unless you've got specialist equipment, hydrogen alpha, calcium K-line telescopes, or you use some specialized solar filters, not arc welding goggles, not a piece of old photographic film that have been overexposed, proper, eclipse glasses, as it were, which you can buy. A lot of astronomy shops and can sell you those. If you want to watch it, as Terry said, it's not going to be a full solar eclipse or an annular solar eclipse, which we tend not to get very often in this country. You need to go abroad typically to see them. You check. I know people that chase them all over the world, Terry and myself included. We've been to several. It's worth seeing. It's one of those things, seeing a little bite taken out of the sun and realizing that we're at this very unique point in the solar system. We're at this really unique point where we've got a moon orbiting us 400 times closer than the sun, which we're orbiting. But occasionally, due to the intersection of the orbits, one passes right in front of the other. And because one's 400 times smaller than the other, they literally exactly kind of overlap, as it were, blank each other out, and you get these spectacular eclipses. We're not going to get them forever. In a few hundreds of thousands of years, the Earth's orbit will have changed, and we will only get annular eclipses. We won't get total solar eclipses. So make the most of it while you can, because they're not going to be with us as a planet forever. On that note, we'll see you on October the 25th. Massive thanks again to great friends at Space Store. Pop along to the Oxford store. They've got loads of new stuff in, loads of really exciting new things in as well. Christmas is coming as well. People start thinking about Christmas now, which is bizarre, but people do. They've got loads of really funky stuff in if you're looking for a really exciting and interesting present for your kids for Christmas. And I'll hand you back to Space Store.
Yeah, I mean, thank you so much. Thank you to everyone who's tuned in to tonight's show, and thank you as ever to Nick and Terry. One thing I will say is do check out our new range of Johnny Rocket merchandise. We're great friends with the author of the Johnny Rocket sagas, John Chapman, so go check those out. We've got some great products in. It's usually anything between 5 and 15-year-olds. Love that sort of stuff, so go check that out on spacestore.co, and we'll be back again, as you guys alluded to, on the 25th of October for our next roundup. Until then, please do subscribe to our social media channels to stay up to date with what's happening with us here at Space Store. Until then, take care, guys. Have a lovely rest of your evenings. Tune into the football while you can. I think it's still going, and have a good rest of the evening. Thanks, Nick and Terry. We will see you guys.
Bye. Thanks all. Bye.
Bye. Take care, guys. Bye.
And we stayed within
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Stuff. Adios, amigos.
Bye all.